Can you hear me? Okay, good. Hopefully they come in. And unfortunately, my phone is dead because I need a new charger.
Oh no.
But I'm waiting till I get to the Apple store in the US because everything is more expensive in the EU. So maybe someone's trying to call me on my phone, but I have no idea because I'm trying to keep my battery alive so I can talk to my parents when we're done.
Makes sense. Kara is sending a message saying she can't see, she's here but can't see us, and I don't see her. I see them as on the list of attendees but not panelists, that's why.
She's joined the wrong link. She needs to join the panelist link.
Yeah.
Let me text her.
And also I see Lene, I'm here and I see you. She's that you Zita and Kara, you have joined as participants.
I can find the Glycan Age panelist link. I'll be right back.
You can put it into the chat here. That'll be great. Did it go in? Because I can't see the link. Yay.
That's what I used. And
There's neat. Have you posted? She can't see it because I think you posted it to hosts and panelists. You have to post it to her.
But if I post to attendees, it'll post to every attendee.
You can just post it to her if you do this.
Yes, gotcha.
To Zita.
Yep. One sec.
Also, Bilhen, can you do it at the same time to Kara?
And I'll do it.
Try and resend emails actually right away.
Okay. Hi, Nicolina. How are you? Can you hear us?
Yes, I'm a little bit ill. Give me one. Oh, good. And I've just had a look at the presentation a few minutes before start. So cool. That's fun.
We won't be able to incorporate it because we just got everyone's slides in, and I can show you what we have.
Okay.
Bilhen, we're not live yet, right?
No, I
We
don't
are.
think so.
Are we live?
Yep.
Oh, okay. Then no.
Live. But do we let other people in or not yet?
I think there are 2 other attendees and we're waiting for Kara and Zita to join through panelists.
Okay, so the audience is telling us we're live. So we're live. Hello.
You're having technical difficulties.
Good to know.
So they're the slides we've had from before, but I think you'll recognize them.
Okay, we'll make it work.
Yeah. Hi, everyone that's coming in. Welcome to our webinar. We are just working through some technical difficulties with 2 of our panelists. Hopefully they'll be in shortly. So this is always my fun time during a webinar because it's like anxiously waiting for everybody to come. And then also talking about my favorite subject, which is the ovary. And I am joined by several of wonderful colleagues that I have here today. So with me first is Nicolina Lauk, who is the co-founder and CEO of Glycan Age. You want to just wave to everybody? And also Joshua Johnson. And we are waiting for also Dr. Kara Goldman, Dr. Zita Santos, who will be with us momentarily. Okay, so if you've recently joined, tell us where you're joining from. We'd love to know. Okay. Hi, Meyer. I think we have someone joining there. Oh. There we are. We have Dr. Kara Goldman. Wonderful. We have Natalie from the UK. All right. We have Dr. Cap. We have a Marina from Greece. Thank you so much. Someone from Romania. All right. Thank you for joining. And we have one more person that we're waiting for, Dr. Santos, to come, and then we will get started. So we have a couple more minutes. We have 2 more minutes, and then we'll get started. Since living in Germany, I try to be on time. It's my goal in life. So, okay. We'll give them a few more minutes. While we wait, please put in where you're dialing in from. Thanks for joining us this afternoon or this evening, depending on where you are. Anyone else from anywhere else? Let's see, I'm trying to go back to the chat to see. Well, so we'll get started and hopefully Dr. Santos will join us momentarily. I think, let's see, we have one more person in the chat saying where they're from. Arizona, wow. Thanks for coming in. Zita, if you can hear us, you're not in yet, but you will be in shortly, hopefully. And then we can get started in 1 minute. Hope everyone's doing well. It's October. I hope everyone's getting ready for the fall and exciting things coming up, such as Halloween or Thanksgiving if you celebrate. I'm always excited for both of those holidays. Ah, there's someone from Canada. Okay, so your Thanksgiving is this month. All right. So, okay, so we'll get started. And first, I wanted to make sure that everybody can hear and see us. Just put it in the chat if you can, and we'll get started. So I'm going to introduce my colleagues. So again, we have Dr. Joshua Johnson, if you just joined, Dr. Kara Goldman, please wave, and Nicolina Lauk, and then we're getting Dr. Santos in momentarily. And
I'm here, Lene.
Yeah.
Finally.
Hi, Dr. Santos. Yay, welcome. Great.
Sorry.
And it's going to be weird to call you all Dr. because I don't call you that. So I'm going to now switch to first name. So I'm going to introduce myself. Hi, my name is Dr. Lene Brayboy. I'm a board-certified reproductive endocrinologist, as well as a fertility specialist and an egg biologist. And the way that I know all the lovely people here on this webinar is because we have all met at a conference. And that conference was all about reproductive aging, specifically ovarian aging. And so this is why I wanted to have this webinar. This is a place that I want us to actually have an exchange of ideas and also talk about the pressing issues in ovarian aging, but also open that up to the public. Often as scientists, we're by ourselves in our labs or our places of work, and we don't get a chance to really interact with the public. So this is our chance to do that. So again, this webinar does not replace any medical advice or treatment. Please speak with your doctor and your healthcare professional about your individual health concerns. And this webinar is being sponsored by Glycan and Ovum. So I wanted to introduce you to Ovum. Ovum is a hybrid IVF clinic, and we leverage AI tools to help improve reproductive outcomes in IVF. So we use cutting-edge technology, we have transparent pricing, and we also have a patient companion app. So that is Ovum. We have 2 clinics, one in London, and we're building one in Lisbon, outside of Lisbon, actually, in Cascais. And hopefully Zita and I will be collaborating very soon. So I'm going to turn it over to my first colleague, Nicolina, if you'd like to introduce glycan age and why are we here talking about glycans in general?
Hello, everyone. So I have a bit of a cold. I apologize for my voice. So we met this, I can't believe it was actually almost 2 years ago at this conference. So we're a company that spun out of a glycobiology institute. And we discovered that you can measure aging on a molecular level by looking at glycans. And the process we measure is this inflammaging process, or this accumulation of damage to the immune system throughout time. And we know this is very related to women's health in the aspect of menopause, but also to general reproductive health, because irregular cycles because of PCOS or other conditions would also make your glycans more pro-inflammatory. And what we want to do with ovum is explore how connected this is to fertility and fertility outcomes. So we are starting a study together that I think we collected one of the first samples maybe a few days ago, so very early on. We look at glycans on your adaptive immune system, and they would add it, give it function, this pro-inflammatory or anti-inflammatory function. And then if you switch to the next slide, if this is the right presentation, these pro-inflammatory structures would accumulate with age. So you have more of a background level of systemic inflammation that would lead to chronic conditions and be a risk for mortality. While when we're young, we have more of these anti-inflammatory structures that protect us. So if we go on to next slide, with biological age, so our first product to the market is a test to give you your biological age. We also have a whole portfolio of prognostics indicating where this inflammation will go. Will it be a cardio problem for somebody or a metabolic problem? With glycans, we can actually distinguish these signatures and tell what risks you're heading towards. But in terms of biological age, it's supposed to give you a better indication of your health versus your age, because we all, although we all have a similar, let's say, maximum lifespan, life expectancy is very different, even within countries. So for example, in the UK, there's a 17-year difference of life expectancy depending on where you live in the UK. So if you're in Richmond, you live 17 years more. If you're in Blackpool, you live on average 17 years less. So it's something that's very influenced by our environment, but also our behavior. So if we go on to the next slide, and we can actually skip over this one to the next one. Sorry. It is something we can influence with our lifestyle choices. And we've done a number of different studies on both lifestyle interventions and some drug interventions. And if you skip to the next slide, I'll show you which ones. So with lifestyle, we first started with the physical activity and nutrition. And we can see that if you lose weight or if you moderately exercise, this will lower your biological age. Sleep is really important. For example, if you're diagnosed with sleep apnea, this gives you an extra 7 years on the clock. And actually, mental health is one of the bigger drivers that we're just beginning to study more closely. For example, if you have a diagnosis of post-traumatic PTSD, I'm highly dyslexic, PTSD, not PCOS, this will give you 15 years extra on the clock. So that's, if we put it into perspective, post-pregnancy usually have a 10-year acceleration that recovers. Menopause on average gives you a 10-year acceleration. PTSD gives you 15 on average. So it looks like stress or mental health is an even bigger factor than hormones, where we have a lot of research yet to do. And then, of course, there's some drug interventions. We see estrogen has a huge impact, and it has been shown that estrogen prolongs lifespan in general. So this is data that came recently from the UK Biobank, and they looked at all the commonly prescribed drugs that have an impact on lifespan and reduce all-cause mortality. And out of 406 drugs, majority of them shorten your lifespan, but 14 of them prolong it, and 4 of these were estrogens. So estrogen is a validated longevity drug, and we see the glycans respond to it very positively. Of course, it should be the right level of estrogen, because we all have different levels, and it shouldn't be too much, too little. It's not that estrogen itself is anti-inflammatory, so you can't treat autoimmunity with it, for example, but it will restore homeostasis. So if you find the right balance for you, it will bring your body back to homeostasis. And then there's some supplements that have an impact, weight loss. We've done a recent trial with weight loss drugs. It was in diabetic population, and now we're doing it in non-diabetic population. So there's many interventions you can do. This is something highly malleable, and it will prolong your future health span. So if we go on to next slide. I think that's the study. Do you want to pick it up from here?
We can pick it up from here. I just had a couple slides to sort of explain kind of ovarian aging. Now, Cara is going to go into this in a much more detail, but I just wanted to make sure everybody listening, perhaps those who will be listening later to the recording, first of all, let's talk about ovarian aging, just as a precursor. Where are the ovaries? They're in your pelvis, right? And typically we have two that we're born with. And the ovary is responsible for multiple things, but one of the things is obviously producing gametes and hormones that Nicolina just talked about. And those hormones have an impact not just on our reproduction, and the ovary also maintains early pregnancy, but those hormones have an impact on all of our physiology. So our cognitive function, our immune system, as you mentioned, our cardiovascular system, bones, which is really important. Obviously your hormonal health, your genital health, so your urinary tract, as well as your mortality, your overall mortality. So the ovary does more than just help you become pregnant and does more than just fertility. So the ovary is valuable to us. In fact, I like to leave everyone with this image of the ovary as we talk about it, because if you recognize this is a miner and he's holding a canary, and the ovary is the canary in the coal mine. It tells us if something is wrong with the ovary, that perhaps there's going to be something overall wrong with your health. And so that's why we're here to talk about the study. Nicolina, you're welcome to introduce it now. I'll go back on mute.
Yes. So I mentioned we have this connection to menopause. So in general, we see that aging would look differently from an immune perspective in men and women. And if you compare men and women, women would be more anti-inflammatory pre-menopause. And then this period, perimenopause to menopause, their rate of aging would double, and it would accelerate, and it would pick up on the same line as men. So when we compare men and women post-menopause, they look more similar. Now, and that happens years before you actually lose your final cycle, or in this perimenopause period. Then we had another trial we did with 70 women in Japan, where we tracked their cycle weekly, and we were looking at these pro-inflammatory, anti-inflammatory shifts within a cycle, and there would be a little bit, it'll be about 1%. So it wouldn't change your glycan age, but we would see a bit of a shift. And if somebody had an irregular cycle, then we would see more pro-inflammatory glycan. So we're wondering, how does this connect to fertility in ovarian aging? And we lose fertility sometimes even a decade before we fully enter menopause. And there's very little known of why we lose fertility. So and inflammation could be a valuable part. So that's something we want to explore with ovum, where we look at the correlation to other markers that would indicate your fertility, like AMH, which is not I think Leanne can tell you much more about that than me, but it's not a perfect teller for your fertility, and also if it is predictive of an outcome with IVF or egg freezing. So that's the idea of the study. And if we go to next slide, I think we tell a little bit more about what a participant would be given. No, I think this is one of your slides.
This is actually our slide. So essentially, we are recruiting anyone who's either doing egg freezing or IVF, and we're doing a sample collection. So there's nothing extra that you have to do. We would collect your follicular fluid, which is the fluid that surrounds the egg, and also a blood sample. And we'll be looking for glycans in those samples. And then we will correlate that with your reproductive outcome. So how many eggs were retrieved? Did you have fertilization? How many embryos were made? And so this is the premise of the study. And you do have to go through IVF, but there are some benefits. And you were just about to talk about this, Nicolina.
Yes, so within the study, you'll be given a free product at the beginning. So we will give you a full glycan age report together with a one-on-one consultation with one of our longevity specialists. And then there will be a follow-up afterwards as well. So it's free access to the product alongside something that you're already doing, and hopefully giving you a little bit more insight on the health of your immune system and aging process.
Thank you so much, Nicolina. I appreciate you being here. And I'm so glad that we had that chat way back in Palm Springs several years ago. I think it's been more than 2. I think it's been closer to 3 now. And we finally have the study going. But, you know, for those watching, science takes a long time. So I'm super happy to have 3 scientists here. And first up is Dr. Cara Goldman. a co-physician scientist, and we are going to talk about ovarian aging and then also about mTOR and rapamycin. So I'm excited. Kara, over to you.
Well, thank you so much for having me. It's great to be here and great to see all of you again. I suspect the formatting might be different on what you're sharing than what I have, so I may actually want to share my own slides if that's okay, unless you would
We can
prefer.
do that, but we tried to do PDFs of all your slides. This is the
Sure.
only one I think we
Okay.
didn't format
Perfect.
properly.
Okay.
We weren't
Then
sure
we
what
should
the
be good.
original looked like. So
Perfect.
here
No,
we
we should.
go. Let's see. I'm not in
Um,
PowerPoint. I'm in Canva.
okay.
It's like I've crossed over since
Good.
academia. I'm in special
Wow.
techie things now. So
Amazing.
yeah,
All
these
right.
are your disclosures, and I can go from there.
Perfect. Yeah. So I'm on the scientific advisory board of Wonder Health, and I'll be talking about preclinical data. So again, just as Lene did, making it clear that these aren't medical recommendations. These are preclinical data that hopefully we'll be able to translate one day to a medical recommendation. And I will be talking about people with ovaries as women. So there are really two pieces here that we're talking about. There's, the ovaries age inevitably, and that's physiologic ovarian aging. So we have this limited pool of primordial follicles that Lene referenced, about 1 million at birth, about 300,000 at puberty, about 1,000 left at menopause. There's, an ovulation every month, about 400 times in a woman's lifetime she will ovulate, but every month you lose 1,000 follicles more from the primordial follicle pool. And so that's physiologic ovarian aging. The average age of menopause is 51, and this is just an inevitable process. The other side of the coin is accelerated ovarian aging. So there are a tremendous number of causes of premature ovarian aging or early ovarian aging. There's genetic reasons, disease states, environmental exposures like smoking, and iatrogenic causes, things like exposure to chemotherapy, radiation, and surgery. And if you could advance. And so, and again, sorry about some of the formatting, looks a little bit less pretty than it did before, but it's totally fine. There's these stages of folliculogenesis, and the reason we're going to talk about it is because it matters when we think about some of the targets to protect the ovary. So eggs are basically laying dormant for many, many years in primordial follicles. The follicles are essentially the nest for the egg, the home for the egg. And eggs advance through these different stages of follicle growth in the ovary. They go from primordial to primary to secondary to antral, and antral is the stage at which it's ready to ovulate. And if you advance, when we lose a threshold number of egg cells, this results in menopause, regardless of what age that is. And Lene went through exactly what I was going to refer to here, that essentially it's so much more than just fertility, and we worry about every organ system being affected by menopause. But talking about infertility, this is a tremendous source of concern for all of us who practice fertility medicine, reproductive endocrinology. This is what we see every day. Are patients who come in and say, why did no one tell me? Or, how has my window passed when I am 40 and at the peak of my life and every other part of my life? And unfortunately, we know that women are delaying childbearing worldwide. This is on the left, some data from the US, 1970 to 2006, the average age of a woman's first birth has continues to rise even further. The average age a couple of years ago was 26.4 years. We now know that women who pursue advanced degrees, college and beyond, the average age of a first birth is more like in your 30s. And so we've got this very narrowing window. This is happening worldwide. So I know many of you are all around the world, and this is happening everywhere. And so if we think about ways to protect the ovaries, we really have to think about protecting those early follicles that live dormant for many years before they're activated. And that's what we're going to be talking about for just a few minutes. And that's the work I do, looking at a drug to preserve primordial follicles. So mTOR is a pathway that's critical to activating those follicles from the primordial resting state to the primary state. There are a number of factors that cause this pathway to activate, but essentially this is a ubiquitous pathway. It's present in kind of throughout the body. It's a very important pathway. and it ultimately results in cell growth, cell survival, proliferation, but activation of the pathway also results in activation of follicles from primordial to primary, and then they are destined for either ovulation or cell death. And mTOR dysregulation is, this person did have a top of her body, but
Okay,
mTOR
we get it. We
dysregulation.
get it. This body was whole at one point, but
This person was whole. Dysregulated mTOR signaling is implicated in a number of disease states and pathology. And so there's been a tremendous amount of interest in mTOR inhibitors in the longevity space. I'm sure there's a lot of overlap here in who's attending and has been interested in some of those interventions. But essentially, the idea is, rapamycin and mTOR inhibitors in general have been looked at for longevity, and there is also a reason to find them to be attractive medicines also to protect the ovaries as well. And so when I entered this field, and as a disclosure, I take care of all people, but I am particularly interested in preserving fertility in people with cancer who are exposed to chemotherapy, chemotherapeutics and radiation. And so one thing that's really lacking in that space is ways to protect the ovary. We can freeze eggs, we can freeze embryos, we can't protect the ovarian function, which leads to all of those sequelae that we talked about earlier in terms of, what happens when you don't have ovarian function. So, one thing that's really lacking is a drug to protect the ovary during chemo. And so we looked at, can we use mTOR inhibitors to protect these follicles during chemotherapy? And could we think about also using them in the broader sense of ovarian aging? So if you advance, we thought about using two mTOR inhibitors, RAD001 and INK128. One inhibits mTORC1, which is just one complex, and then mTORC2 is the other complex, and INK128 is essentially the drug that suppresses both mTORC1 and mTORC2. Thank you. And we looked at essentially if we give these drugs to mice and give them alongside the chemotherapeutics that are particularly toxic to the ovary, can we protect the ovaries? And we found that giving these drugs in conjunction with chemotherapy drugs preserved the primordial follicle pool, and ultimately in subsequent evaluations preserved fertility. And what this is really looking at is I've broadened this a bit because ovarian aging, of course, is so much more than just the impact during chemotherapy. And can we extrapolate this out to look at ovarian aging from the broader sense? And so we've done mouse work looking at using mTOR inhibitors in a mouse model of ovarian aging. And then when we do that, are there any impacts to transgenerational offspring health and fertility? So are any of these agents potentially going to affect the next generation? And so that's mouse data that I'm not going to talk about, but we also have data looking at, what are these pathways doing in women who are getting their eggs retrieved for egg freezing or IVF, when we look at young women and reproductively more mature women, and how is the mTOR pathway expressed differently in these different age groups, to really get a sense of, yes, we see these effects in mice. Can we think about applying this and translating this to humans as well? And then I just want to completely shift the conversation for just a moment, because again, I'm a clinician. And so at heart, I think about the patient sitting in front of me and, how we need to do better in terms of talking to our patients. A student and I, a few years ago, looked at a systematic review of, how are we talking to our patients about ovarian aging and how can we be doing better? And essentially the guidelines, the spoiler alert here is that the guidelines are really poor. So we have, we're not helping our clinicians counsel patients better. And so patients are getting their information not from their physicians about how their ovaries age. They might be getting it from TikTok or wherever they're getting it. And we know that they're not getting well-informed. And so a well-informed patient can make a well-informed decision about how to build her family and protect her ovaries. And so we need to do a better job of counseling our patients. And that is all I have, but I'm thrilled to be here, and thank you for including me.
Thank you so much, Karen. Thank you for dealing with some of the slides shifting, but you did a great job, and I think you you conveyed the message. So now we're going to move on. So Zita, I'm not going to say Dr. Santos because I can't. It's just weird. So Zita, I had asked you to come to this panel, and you were like, "Oh, this is more clinical, but what I do is more basic." But I want you to talk about your basic work, because without basic work, Kara and I wouldn't have a job. Someone worked on a sea urchin and a starfish to describe IVF originally. So take it away to tell us about you and your work and how it relates to ovarian aging.
Thank you so much, Luna. So I would really like to start by thanking your invitation. I think this is really great that we get together these different group of people, like doing different things, and kind of bringing together more of the fundamental research to the really applied. So it's very, very, very cool to be here. So yeah, I have recently started my own lab in Lisbon. We started in the Institute of Molecular Medicine, which has now merged to a second institute, the Gulbenkian Institute. So I'm now in GIM officially. And kind of the broad general question of the lab, what we are interested in is understanding how cellular metabolism regulates physiology. Okay, and so if you want to move to the next slide. So what is metabolism, right? So I think that's kind of a key maybe aspect that people should know about, right? So metabolism is basically the complex processes that cells have to go through to transform the nutrients that we uptake from the diet into other substances, other what we call metabolites, that fuel a variety of functions in the cells. Okay, so all cells undergo through these processes, and they're really critical and key for every function that a cell does. Okay, and so basically our lab is interested in understanding how the nutrients that we acquire from the diet impacts physiology. Okay, and basically we are interested in this arrow that goes from nutrients to cellular metabolism and then to physiology. Okay, and we have been focusing quite a lot in a specific component of the diet, the carbohydrates, which we usually, one sort of carbohydrates is sugars, right? The ones which are the less good, and these are the ones which we have been focusing on. And most of our research has been focused on ovary. Okay, so we have been looking a lot into ovarian physiology and function, and that is kind of how we got into this field as well and got to know Lene. And obviously on this branch of metabolism and carbohydrate metabolism in specific, right? And so we have been focused. So our outputs are obviously, or the outputs that we are interested in is fertility. Okay. And another aspect which we have been looking quite a lot is how the physiology of the ovary not just impacts fertility, but also impacts appetite. So we are kind of working in this feedback, what we think is a feedback loop between nutrition, how that feeds the function of the ovary through metabolism that happens in the ovary, but then on another turn, how the physiology of the ovary could impact appetite and nutrition. So we are trying to find out which are the loops, feedback loops that happen between one and the other, okay? And so if you can go to the next slide, Lene. So the good thing that we have while working in a more fundamental lab is that we can manipulate specific aspects of our system in order to understand them and to kind of fully understand how each specific component of these maybe complex interactions impacts this phenomenon, right? So for example, in our system, we can modulate nutrition, we can modulate whatever nutrients we provide to our animals. And we can also modulate the metabolism per se. So if you can go to the next one, we can specifically impact metabolic enzymes, which are kind of the factories that change our nutrients into another substances and other metabolites, right? So we can do that trick in our animals. And by doing that, we can understand what is the impact on physiology, okay? And so this is the nice thing about working with model systems, model organisms, is that we can tweak the system in order to better understand it, right? And so we have been doing this to understand how changing nutrition can lead to metabolic adaptability, right? So what are the limits of metabolic adaptability, and when do we break that? And then on the other hand, we have been also very interested in understanding how cellular metabolism, I was telling you about, impacts physiology. And this very much focused on ovaries physiology, but then going from the cell to the tissue to the organ, and then eventually to the whole animal. And so one of our aspects which we have been focusing on is how these different interactions between nutrition, cellular metabolism, and ovary change, right? And one of the aspects which we have been looking at is aging, obviously, and much because of what has been said already, right? The ovary is a very special organ which ages at a different rate than most organs in the body. And so this is kind of a very interesting paradigm to understand if there are any metabolic changes which are associated to this decay, right? Fast decay. And so the fun part of the story is that we are using a model system which is quite far away, if you know, at the first sight, from what is a human, right? So in the lab, we use a fruit fly as our model organism, and these are the flies which really, you know, you find them often around your bananas at home. So these are the same flies that we use in our lab. And I just wanted to tell you a little bit about this system and why we use it, right? So Drosophila has really a number of advantages, right? So to start with, and to maybe our surprise, it is not as different as us. So around 60% of the genes that are found in Drosophila are also found in humans. And I think this is quite amazing, right? And so that means that we are very likely to study genes or components of this animal, which might be important also for humans, right? The other aspect is that around 65 to 75% of genes that have been found in human to be cause for disease also have a functional homologue in the flies. So those same genes also exist in the flies. And in most cases, they have been found to be expressed in tissues which are similar to the ones in human. So there is kind of a very nice correlation between function of the genes, okay? Other than that, in terms of what I do and of the interests of the lab, the metabolic pathways are very, very conserved, and the genes and the enzymes of these pathways are super, super conserved. And so the biggest advantage of using Drosophila is that we can easily manipulate it, okay? And this is either in terms of genes, in terms of the diet. So it's has a short-lived, so we can get many individuals per experiment. So that means that we can very fast you know, study or ask a question and discover basic fundamental biological answer fundamental biological questions, right? And so in terms of ovarian aging, I started to realize that I need to have always this kind of image to show that in fact Drosophila and human oogenesis are quite similar. In many ways, they are also different in some ways, but I think that there are some correlations that we can make between the two. And this goes for the cell types that we can see in terms of ovary, companion cells, and all of that, the stages that they go through, hormone production. We also have steroid hormones in Drosophila. So there are many correlations, and I think this is very interesting to kind of make these parallels, right? The other thing is that, so this is a study that we did, is that we also see a reproductive decay, which is kind of similar to what we see in humans. So also Drosophila undergoes a very fast decay in reproduction. So the average lifespan of Drosophila is around 50 days. And we see that both the number of eggs, but also the quality of these eggs reduces quite dramatically in the first third of their life. So we can study physiology of the ovary. We can also study aging of reproductive decay in Drosophila, and so this has been our model system. And so hopefully we can at some point start bringing this some of our findings into mammalian system or even human system. So that would be very, very exciting. Thank you so much, Lene.
Thank you. Thank you. And if you've just joined, Drosophila are those pesky fruit flies that are always in your kitchen. You can never get rid of them. They
Never,
have
ever.
never, ever. I've tried many ways. I put out port wine for them. They're always there. So anyhow, we're going to move on now to Joshua Johnson, Dr. Joshua Johnson, who is our final speaker. And I'd love for you, Joshua, to introduce yourself and tell us about your work as well at University of Colorado.
Sure. Thanks for the invitation, Lene. And it's an intimidating group to be a part of, presenting our work. And like Dr. Goldman and Dr. Santos, I, am very, very interested in the ovary, both in terms of its physiology and general function and support of human reproduction, but also how might be able to manipulate the organ to, improve health span and lifespan. And the introduction that Dr. Goldman gave was about perfect. I couldn't think of anything to add to how the human ovary functions over time. And my slides are short, as you'll see. I suppose a bit about myself. I'm a PhD, and have been interested in the basic function of the organ, but also can we, learn anything that's going to be translatable to human outcomes? And I hope so. So if you go to my next slide, the only thing I might add that's any different than what we've heard is that we've done in the last few years a lot of collaborations with mathematicians, one at the University of Utah, Sean Lowley, and the other at Yale University, Jay Emerson. And our general scheme or thought process is that if we do wet lab experiments with model organisms like mice, like human ovarian cortex tissue, and even like fruit flies that I'll get back to, maybe we can learn things that we can then apply mathematical models to, gain some insights from the modeling, and have that feed back into design of wet lab experiments. And, in the best case, maybe some clinical actions, some changes in practice that might, extend fertility, extend ovarian function. And then the longer range target is whether we can improve health and lifespan of women. This was mentioned at the beginning by Nicolina. So if you go to my next slide, we keep things very simple and focus on what Dr. Goldman mentioned. Ovarian follicle depletion is the causal reason for the decline in ovarian function. Periods, menstrual cycles depend on the availability of growing follicles that make hormones. When growing follicles are available in a predictable pattern, menstrual cycles are regular. At the end of the paragraph here, I point out that, when no menstrual cycles occur, too few growing follicles are available to produce hormones to support any menstrual cycles. And our most recent work in the bottom right is the citation. We showed that the limited and erratic supply of growing follicles actually is mathematically predictable. We know around when the supply of growing follicles that will make hormones are produced in this erratic way, and when they become too erratic to support normal menstrual cycles. So that's, I think the main thing I'll add. I will just briefly mention it was great to hear the three prior presentations, because my lab some time ago fed fruit flies rapamycin. And so that publication is available if you'd like to know how rapamycin in reasonably high doses impacts egg production in flies. So if you go to my last slide, or second to last slide, we keep things very, very simple. Dr. Goldman mentioned, around birth, girls are born with maybe 1 or 1.2 million follicles. That's the blue dots, the ovarian reserve at left. The very simplified way I think of it, moving rightward, a certain number of follicles will begin to grow per unit time. The blue ones survive, the red ones die. As we move rightward, follicles are getting larger, oocytes are getting larger. And every month, around 1, the green large oocyte would be ovulated and available. Dr. Goldman mentioned most follicles, the red guys, will die. If you go to my very last slide, we focus on this very simple decision. What is the cue for individual primordial follicles to begin to grow? I mentioned this, appeared over years of just looking at ovaries and monitoring the, things experimentally, reviewing literature. This decision appears to be quite random, right? We don't have a good sense of which of these individual primordial follicles will begin to grow. And it turns out our trick that led to our recent publication describing the overall pattern of ovarian aging stems from, if you do treat this process as a random process, it produces not only the believable pattern of follicle loss in individual women, but also produces the patterns of menopause onset and also the pattern of the menopausal transition onset. And anyone can ask more questions about that or reach out, and I'm happy to provide publications or more information. So again, I'm really grateful to be here with this particular group. Thank you.
Oh, wow. This is great. I feel like I feel renewed because sometimes when you're doing research and science, it can be quite hard to start, right? And to be in the company of other people who are doing research, who have also been through that struggle, is really important. So we're going to first see if there are any questions in the chat, and then I have some questions for each of you. So first up, we have, let's see, in the chat. Let's see. So we have a question from Meyer. Meyer says, red meat activates mTOR pathway. So would excluding it from the diet, excluding it from diet, is it significant for ovarian health? I'll give that to you, Dr. Goldman.
It's a great
Should we all stop
question.
eating red meat?
That study has not been done, but I think it brings up larger questions. We know that many things activate the mTOR pathway. So I think it would be hard to narrow it and say that this one intervention would be the thing, would be the thing that makes the difference. Certainly, I think that there's some truth to that if we look at other exposures that cause significant activation of the pathway, I think those are good targets to study. But, too early to say that link exists. But I think that there's some truth to evaluating those targets and saying, like, is this something that we should be further looking into? Is a vegan diet going to be the thing that protects the ovaries? I think the answer is none of these things in isolation are going to be the thing. But I think we're going to have to find a number of interventions that make a difference, and a significant difference.
We have another question. So what is the normal change in ovarian reserve over 20s and 30s? So Dr. Johnson, I'm going to give that one to you. Do we know?
Sure. Well, because it turns out that girls can be born with nearly tenfold span in primordial follicle reserve, it's an interesting one. If you're born at the lower end, that means by the time you reach your 20s and 30s, you'll have fewer follicles remaining than someone born with 10 times more, right? Mm-hmm. And so you're into either the tens of thousands to perhaps still having 100 or 100,500 by then. So I would say that with the backdrop of all of the factors that can modify the number of follicles remaining over time, that number that you're born with is extremely impactful and dictates how many you'll have in your 20s and 30s.
So it's different for everyone. And maybe, Zita, this is a good question for you. What about in flies? Do they have similar ovarian reserves, or does it vary from fly to fly, or does it vary based on their nutrition?
Yeah, so that is actually one of the difference between flies and humans, is that flies keep stem cells as adults. So they can produce a new cell that will generate an oocyte in every cycle, right? So in flies, you don't really have cycles, so they are constantly producing new cells which give rise to oocytes, and the stem cells are still present. So what happens is that during decay, these cells start to be lost. Okay, so this rate of decay, the decay also in proliferation happens, but the mechanisms which are behind it, we don't really know. But that's actually one of the difference between a human and flies, is that flies can replenish, right? So there's not a finite number which is predefined, right? And so this is something that it's quite critical, yeah.
Okay. We have another question. This is for Dr. Joshua Johnson. Please elaborate on the mathematical model that describes follicle numbers in relation to E2, E3, FSH, LH, and AMH. Well, that might be hard all in one, but do you want to try to take a stab at that one?
Sure, I'll go through each of the hormones in turn. No. But what I will attempt to do is give a backdrop for how we can get our head around how these hormonal changes occur, let's say within a menstrual cycle and then across aging. And so if we start by imagining a young adolescent, maybe soon after puberty, before age 20, the number of follicles in the ovary in the primordial reserve is very, very high, right? You're still talking, over 100,000. Monthly, of the perhaps 1,000 that begin to grow, very few of that 1,000 will survive to contribute to hormonal production. And some of our best estimates of the numbers of follicles that are growing at any time would be an ultrasound measurement that would be done in the clinic by people like, Linnae and Cara, where the number of antral follicles, those with a fluid-filled cavity, tells us how many at that moment approximately are surviving to make hormones, right? And so as women age from that 20-year-old or short of 20-year-old, that antral follicle count will decline as the primordial follicle reserve declines. And so there are fewer and fewer follicles that will survive to make hormones. Monthly, or at the peak production of hormones, there are plenty, and there are plenty to keep menstrual cycles going, as I mentioned. Okay, so let's switch to as aging continues, as women, approach their menopausal transition, when periods become irregular. At that time, the supply of growing follicles goes underneath the number you need for regular cycles. And what does that mean? That means that too few, when a cycle is interrupted or lengthens, too few have survived to produce the hormones needed for feedback to start the next menstrual cycle on schedule. And I'll say that, a slightly different way to account for the hormones this person mentions in the question. And so if large follicles are there making estradiol, the number that survive that cycle to produce estradiol is informed by the mathematical model, by the number that are surviving that cycle. And so our model works backwards to the supply of growing follicles becoming erratic. That erratic nature of the supply leads to an erratic number that survive to produce the hormones that are listed. If it's ovarian hormones like estradiol and it's erratic, the feedback to the hypothalamus and pituitary becomes unpredictable and erratic. So FSH levels will change and will tend to increase over time. AMH, coming from smaller follicles in the ovary, of course, depends on the supply of growing and surviving follicles also. And AMH levels can be, although they can fit into boundaries for an individual patient, they do change month to month, especially as we age towards the menopausal transition. And we would suggest that's why the surviving number of small follicles is becoming more erratic. So I hope that was a useful answer.
I think it was. I think it was a great answer. And maybe I'm just going to do a follow-up question to Cara is, patients come in and they have an AMH and they have an antral follicle count. And I'd like to tell people it's a photograph, it's a snapshot. This is, this just because today you're in the office and this is what you're doing today, it doesn't mean that we can predict what your fertility will be in the future. So I don't know if you want to comment on that, because the next question is about when's the best time to freeze one's eggs. And that's a common question.
Yeah, it's a great question. I think it's the $1 million question is, if we could predict You know, if we had some way to imagine what was going to happen in 10 years, it would be life altering for everyone. AMH is a great snapshot. It tells us how someone's going to respond to medication if they were to go through a cycle now. It also helps us know if your AMH is what it is now, in a number of years, presumably it'll be lower. And then you're going to be less likely to respond to medication if you need IVF then. So for patients who need ART, it helps us time ART. Maybe they bank a bunch of embryos now before they are 40 and have diminished ovarian reserve and respond less well. But no, we don't have a great way to predict the trajectory of AMH. And, you know, we know there's a relationship between AMH and time to menopause, certainly, but we can't map out that relationship.
And that's the whole purpose of our study, right, Nicolina, is that one's chronological age cannot really tell you anything, right? So there is no one age that's good to freeze eggs. And so understanding one's biological age perhaps can also give us a window. Any comments on that before we go to the next question?
Well,
Nicolina?
this is why we're doing the study, because it's also fertility could be very health related, because it does change. You know, somebody who has problems in their with their fertility in their early 30s might actually have a good outcome in their 40s, as, for example, an autoimmune condition goes into remission. So it's more of like this question: what is this connect? And we do have some early studies that lifestyle changes before fertility treatments improve outcomes, or even natural conception. So I think the problem is we know what accelerates infertility or aging. For example, smoking and obesity would speed up menopause. We don't know what actually prolongs fertility. So there's another question on what can we do to prolong, and we don't know because we haven't studied that. So that's one question we want to start to answer. First, to tell if inflammation is related to fertility, because we don't know. Second, if we can predict outcomes from glycans, and then generally just looking at glycans as a new category that hasn't been looked at in this space. So I think this is the first time we'll look at glycans in follicular fluid. That's never been done, and we have no idea what we're going to find. And they are interesting from a fertility perspective, because glycans are a way that our biology would communicate, and they are in a way that we would enable conception. So the only reason we have conception is because sperm coats itself in sialic acid, which is this really anti-inflammatory glycan to evade a woman's immune system. We're hoping that we'll find some new discoveries that, you know, we haven't even thought about before, where glycans have some insight.
Yeah. Thank you for answering that. We have one more on this chat. Are there any findings in fruit flies? This is for you, Zita, that bring us human solutions soon? Soon is the operative word.
Soon is the word, right? So I think it's very difficult that happens soon, right? So it takes a long time between making a fundamental discovery of how mechanism happens, right, until you actually have you know, a way to modulate it and to actually impact that mechanism, right, in humans. So you know, science takes times, and going from a basic study until an actual application takes time. But I think we need to have both, right? So you can have two approaches, either starting from the other point where you can start kind of directly, making maybe using a panel of drugs or panel of components that might act right on this on physiology of the ovary, and then ask if that helps, right? Which is a more kind of unbiased but targeted approach. Or we can start from the other side, right? Asking what is going on there, what is wrong in case of infertility, and then acting specifically on those, right? And those take time. So I think we need both, and kind of we are on the spectrum, right? And I think it's quite exciting actually to understand what are the mechanistic aspects which are behind function of the ovary, and then maybe what goes wrong if you have issues with fertility. Yeah. But yeah, it takes time. Sorry.
Well, thanks for answering that. We have a few more questions. We have time for a few more questions. someone says, great webinar. What are some validated preventive measures, modalities, supplements that have been shown to promote youthful ovarian health? Nicolina, do you want to take that one?
Unfortunately, I don't think we know. So there's no study. Well, there are in animal models, and I don't know them well. Maybe other panelists would know more. But if I remember correctly, there was some work done in mice or rats with NAD and with rapamycin that has shown some, but that doesn't mean that we can translate this into humans. And I think there was work in yeast with urolithin A, but I think we're quite far from yeast, yeast to human. I think that needs a bit more validation before we can recommend it. But I personally wouldn't know one validated supplement that's even recommended in a fertility journey that would actually have a predictable outcome. I think everything is more of a working off very little pieces of evidence and assumptions.
Yeah. And there was a follow-up question to that question. Do you recommend the Dutch assay, hormone assay? I don't know if anyone has heard of this Dutch assay. It's an assay with lots of different labs. And it's things, I think, from your thyroid to your ovarian hormones, to your androgens, to C-reactive protein. It's a whole panel. So I don't know, Kara, if you've ever had patients who've walked in with the Dutch panel and said, what do you think? Should I get this? Should I have egg freezing, or am I a good candidate for IVF?
I think with any of the direct to consumer testing that's out there, and there's quite a bit, I think there may be some utility, for example, in having an AMH, because if that brings someone in to have a further conversation
Right.
with someone who might then, advise them to intervene, then that may be useful. I think there's some concern that if you are at home interpreting tests on your own, then there's a lot that could be lost in the interpretation. And so I generally would say if it gives you information, I love an empowered patient, and I think information is great. As long as that information then is, you've got someone who understands the literature who's advising you.
Yeah. All right. So we have time for a few more. We're wrapping up for the evening. I think there's one more in the chat here. Do you think it's possible to reverse ovarian aging? Like Nicolina said, is it possible to reverse biological aging anytime soon? So there's lots of treatments that purport to help the ovary become youthful. But Nicolina, you mentioned some just lifestyle changes, right?
I mentioned that we know what speeds up menopause, smoking and obesity. So taking these two things away is certainly helpful. And you can just say that the reverse is true. If you're not overweight and you don't smoke, then you're more likely to hopefully not damage your fertility. I think there's two challenges in fertility. One is just generally the egg count, which declines. And I think for that, there's the therapies that suppress AMH, where there's nice work in animal models where we can suppress it, for example, during chemotherapy, and preserve ovarian reserve by manipulating this hormone. But there's very little showing that you can preserve egg quality. So I think that's more related to overall health of an organism. And you might still have a good egg count because you preserve you can do egg freezing, but you can comment on that. That has a lot of complexities in itself. But we don't yet understand what governs this quality of the eggs and why it dramatically declines from age 35. And I think that's this mystery that we need to do a lot of science on before we can actually start to give advice on how to. But having more egg count is, of course, great. And there are some therapies coming out for that relatively soon-ish, which is still 5 to 10 years.
So it's not always quantity, and it's more quality, not always quantity. I think that's also important to note, because there's some studies that have shown that some, let's say, emerging techniques have maybe increased egg number, but not necessarily live birth, not necessarily embryos made. So we're wrapping up. I wanted to do a final round to talk about, research is difficult. I think Melinda, I think French Gates has now said that, one of the most pressing topics is women's health. We've always been underfunded. We've always not had the resources. But the truth is that everybody should care about an ovary because we all start our journeys there. We all come from an egg. And that's actually the root of the name for ovum, ex ovo omnia. Everything comes from the egg. So I just wanted to do the last round, final thoughts, most pressing challenges, and what you hope for the future for each of the panelists. So I'm going to start as we started. Nicolina, what's your parting thought for us?
Well, I think my one in fertility is definitely personalization because I have been an egg freezing patient, not yet a fertility patient, but there's a huge lack of personalization. I mean, you can't really predict a response or an outcome or try to improve that per person. It's very trial and error. So I think what you're doing is amazing, and there should be more of that, so we can be a little bit more confident when we go on this journey that it's being personalized to us in some meaningful way versus just let's see what happens.
And thoughts for anything for glycan age for the future?
Well, let's see what we find. If there's a connection to fertility, I mean, I would love to discover a woman's biological age clock, but that's a fantasy at this point. I mean, that's something that I would want to be measuring
right,
life, so I know when to make certain decisions. Because right now we're just guessing, but that doesn't exist, and we don't know if we'll find it. But if we do, that will be a very happy day.
That's the whole point. Science, if you knew what you were doing, it wouldn't be science. So next, Kara, do you have any final thoughts and wishes for the future? Oh, you're on mute.
Thank you. Thanks again for having me. I would just say that so much of what we do in medicine, and especially in our field, is reactionary. So when we treat infertility, we are already behind the ball, and ART is very inefficient at overcoming age-related fertility decline. So I think I love that we are all in this space where we're trying to be preventative and looking at prevention of infertility, prevention of the endocrine dysfunction that comes with loss of ovarian function. So looking more from a preventive standpoint than a reactionary standpoint is what I hope for.
I love it. I love it. And I think, in the US, there's been a public health push, one key question. So everyone should be talking about their family planning with a healthcare provider. How many children do you want? When do you want them? This is an important question to have so that, or, I would say conversation to have so that one can actually act on those wishes before you come as an infertility patient when we are behind the 8 ball, as Kara said. So, and then Zita, over to you.
Yeah.
Last comments, wishes for the future.
So I love that you guys finished, Nicolina and Lina, talking about number and quality. And so this is something that we are really actively looking at the moment. So we are focusing a lot on trying to understand what are the specific nutrients that impact more the quality of the eggs, obviously using fruit flies. And I think this will be very interesting to maybe as a point of action, maybe some related to some of the comments regarding supplements in the diet that might improve, maybe specific nutrients which we don't get access to as easily in our daily diet that we can provide externally, which could have an impact in the future in the quality of the egg. So I'm very excited about what's going on in the lab at the moment, and I hope we can find a very exciting science in the next maybe couple of years or so.
Yes, I'm excited too, and I'm excited about our upcoming future hopeful collaboration.
Me too.
And Joshua, not last but least, parting words for you.
Sure, it's perfect. I was teed up by Dr. Santos with her focus on egg quality, because as I mentioned, I'm very, very focused on egg quantity, right? And so efforts to slow the loss of the ovarian reserve, independent of a woman is seeking, offspring at that time, something that we talk about in my department with the clinicians is if women are identified at risk for primary ovarian insufficiency, losing the function of their ovaries before age 40, what if it were possible to get them to the median age instead of menopause at age 51? What are the trade-offs for their health? There are some gains that would be expected by keeping ovaries functioning longer, but also some increased risks that need to be evaluated carefully. And so in terms of the list you showed on your slide, bone health and adiposity and, genitourinary symptoms, all of those things might be helped in that segment of the population by focusing on egg quality. And I think that work, as was mentioned, is coming quickly.
Awesome. So if you want to know more about the study that we're doing at Ovum Care with Glycan Age, please write us at research@ovumcare. That's research@ovomcare.com. And we'll be more than happy to tell you more about the study. And hopefully we'll publish the results, whether they're positive or negative results, so that at least everyone will have the ability to have access to it. So thank you all for coming to our webinar. We appreciate your time this evening or this afternoon, wherever you dialed in from. And thank you to our panelists again for taking time out of your busy schedules to come. It's been an honor and a pleasure. Nice to see you all. And thank you.
Thank you so much.
Bye.
Thank you.